All right, here we go. The Chapter 9 review. Congrats. Let's take a look at area, polygon, and circles. Again, this is a quick review of everything, so I'm going to go fast. If you need a more in-depth explanation, please go back to the section, watch the video, make sure you got it. But I'm going to go quickly through these to make sure we kind of have the general idea. So, I'll give you all the formulas on the test. I won't name them like this. I'm just going to give you a big list like on the review. You got to choose the right one. So, parallelogram. Opposite sides are parallel. That's what a parallelogram is. Remember, these are parallel to this. It's just base times height, so it's just a matter of finding the base and the height. So, in this first one, let me change colors here real quick. This is the base from here to here, and check it out. The height is how far tall is it this way. So the first one is just 9 times 3.2. Fantastic. What if I flip it around on you? You okay? 10.3 would be the base. The one that makes the right angle is the height. So it'd be 10.3 times 5. Not a problem. Don't cut these in half. They're just straight up multiply them out. Also, remember that squares and rectangles are parallelograms. They just happen to have right angles here. And that's the easiest base times height out there. Along the way, I'm going to throw some other things at you. So this is a parallelogram. I can see the base is 12. What is the height of this? Well, if you check it out, I made a special right triangle. So 45, 45, 90. Remember, I want you to remember, these are congruent. That's what's special about these. And if the angles are congruent, the sides are congruent. This is also, if you go back to the 1, 1, square root 2. So if you say 4 radical 2 is to the square root of 2 equals h is to 1. I'm looking for that height. And this one works out nice, isn't it? The square roots just cancel, so h is 4. So really, you can say, oh, I'll solve the height is 4. If you didn't like these special right triangles, you can get away with using trig on these. It works just the same. Just make sure you type in radical 2 in there. So this is just 12 times 4, or 48. And again, make sure you label these things. This is inches square. We're talking area. Very cool. How about triangles? Can we do some triangles? And I'll cover up the other side here so it doesn't get in your way. Yes. Let's look at some triangles. So same thing, I just drew a couple to make sure you could see them if they were spun around or whatever. Again, this is the base, the height. There's, depending on the side you want to use, it's just the right angle though will give us the height. So this one you do cut in half, it's 1/2, 5 times 6. Because really, triangles are half of parallelograms. Fantastic. I kind of mixed it up a little bit here, but here's the height. The one it forms the right angle with is the base, so in this case, it's 1/2, 11 times 4. And then you can multiply it out. And here what I do, and we had special right triangles, I'm going to throw a little trig at you. I need to know what? Well, in this case, I need to know the base. This is the base because it's 1/2 base times height. So how do I do that? This looks like a little tangent action going on here. Tan of 39 is opposite over adjacent. So solve that for B. Let's go ahead and finish that one out. We're going to solve for B. So what do? We times both sides by B. So they cancel. And then we get B tangent 39 equals 6. So what do? We have to divide by tangent 39. Divide both sides by tangent 39. That'll give you B. Let's just kind of have some closure here. 6 divided by tangent 39. Always double check your mode. Am I in the right mode? Yes, I'm in degrees, so I'm cool. And that should give me my base, which is 7.409. So we found the base as equals 7.4. I'm going to round it. So 7.4 times the height. Good to go. Triangles. Love it. Moving on. What's the next one? Trapezoids. So again, base 1 plus base 2 times the height. So this is just a matter of plug and chug. B1, B2, height. Plug it all in there. Add it all up. It's not too bad when you just plug all those numbers in. So it should be okay. How about this though? Another little thing that I can throw at you is find the missing part. So you have to use the formula to find, in this case, what am I looking for? The height. I don't know the height, but I do give you the area. So you can say the area is 29.7. 1/2. I know my bases are 3 plus 7.8. And you're solving for h. So now once you set it up, it's just a matter of solving for it. So to solve for it, you can do the parentheses first. So that's really 1/2 of 10.8 times h equals that area. And then what do? Half of 10.8 is 5.4. And you're solving for h. So how do we get h by itself? You're going to divide by 5.4. Divide by 5.4. So that'll give you your missing number, whatever that is. You may have to solve for h. Fantastic. All right. How about the other side of this? We got a kite and rhombuses, which would really be rhombi. I love that word, rhombi. So here's the formula. We need diagonals of this one. So the first one, the kite, what are some properties of the kite? Remember, this diagonal is congruent to this. Also in a kite, this is congruent to this. And this side is congruent to this side. And it makes right angles here in the middle. So I love kites. So if that's 22 over there, that's 22 over here. So this is just a plug and chug. 1/2 diagonal 1. So we can say 22 plus 22 is 44. Then if I do the other diagonals, what? 58, 10 plus 48, 58. So just fill that out and you're good to go. Awesome. What about this rhombus I got over here? Well, I know these are right angles. And remember, rhombuses, these are all sides are the same. And the diagonals bisect each other. So this is congruent to this. This is congruent to this. And we've got the right angle action for all those. So really, what do I have here? Well, if you look at just this little triangle, it's 9 by 15. I need the other one, so I got to find this missing side. This time I threw Pythagorean theorem. So special right triangles, trig. Now we've got a little Pythagorean theorem. It should be 9 squared plus x squared equals 15 squared. And then, so, if we simplify this, 81 plus x squared equals 225. And then let's finish this out. Let me move some of these out of the way here a little bit. I'll put that up there. Drop this right over there. Alright. And let's finish this out. Subtract 81 from both sides. X squared is going to equal 225. Oh my goodness, I'm having a hard time thinking of that. 144. That took me a while. And then square root both sides, x equals 12. So all that work was just to find this, which is 12. If that's 12, this is 12. If that's 9, this is 9. Now I have my diagonals. So all that work just to find the diagonals, I love it. So the area of this is going to be 1/2. My one diagonal is 9 plus 9 is 18. 12 plus 12 is 24. Go ahead and solve that, and you're good to go. Fantastic, we're killing it. Moving on to the next section. What do we got here? We got a regular polygon, something like this. Why are they regular? With the regular, all the sides are congruent. So that's what makes a regular polygon. In this case, it's a pentagon. It's got 5 sides. So it's just 1/2 a times p, the apothem. Remember, the apothem is the one that makes the right angle. And then p is the perimeter. So let's do this one. This one's not too bad. 1/2, what's the apothem? 13. What's the perimeter? The perimeter in this case is going to be 18.9 times 5. So multiply that out. That'll give you your perimeter. If we want to do it real quick, 18.9 times 5. Boom, 94.5. So really my perimeter is 94.5. So that's nice if they give you your information. I mean, they kind of hooked you up. They give you a side. They give you the apothem. That's pretty cool. What if they don't give you that? What if they give you this? Here's a regular hexagon. Now you got to start drawing in your triangles to help find the thing, because I really need that apothem. So I can find the perimeter because it's 999 all the way around, but I really need this right here, this apothem. So it all comes up to this finding the central angle. Remember, that central angle is this one in here. So you take 360 degrees divided by the number of sides 6, you get 60. And if that's 60, it's going to get cut in half, really, isn't it? So it's going to be 30 and 30. So that's 30 and 30 makes 60. The whole thing is 60. And now I want to find that dotted line. So what I do is kind of redraw the triangle, just so I have a little bit more room to work. That's 30. So it's a 30, 60, 90. If that's 9, this is really 4.5. So we're looking at 4.5. So can you find this missing side? You can use special right triangles, or you can just trig it up. I'm just going to trig this one up. Tangent of 45, or 4.5. What am I doing? Holy cow. Tangent of what? Tangent of 30. The angle is opposite over adjacent. So in this case, I'm going to times both sides by x to get x out of the bottom. Do not like x in the bottom. They cancel. X tangent 30 equals 4.5. And then what am I going to do? I'm going to divide both sides by tan 30. So the trig is very important in this chapter. Let's just get some closure on this. Clear that out. We got 4.5 divided by the tan of 30. And we get 7.794. So 7.79. So that was what? That was just my apothem. That was this side right here, which is the apothem. So if I do this, I've got area equals 1/2. The apothem was 7.79. What was the perimeter in this thing? Well, perimeter would be 9 plus 9 plus 9, because it's regular. It's all the same. So your perimeter is going to be 9 times 6 is 54, so there's my perimeter. And maybe you notice this, I don't know if anybody knows this, about hexagons. Only in hexagon does this work. I know it's the 30, 60, 90, so I know the radius is 9 in this case. So in a hexagon, the radius and the sides are the same. That's an equal out triangle because that's 60, 60, 60. Isn't that cool? If you like that kind of stuff. Maybe that'll help you out. I don't know, but then you can multiply that and you're good to go. Alright, let's wrap it up. The last section, or actually the last two sections talked about circles. I think, find the area of circle is not bad. Just plug and chug, yeah? It's just pi r squared, so it's just this, or it's 36 pi. That would be an exact value. So sometimes I'll have you leave your answer in pi. Maybe over here, 2 pi r, so it's 2 pi, and in this case your radius is 8. We'll check that out. You get 16 pi. And sometimes I may say, go ahead and multiply that out. What is the decimal value? You can just type it in. I was using 3.14. You can use the pi button. 50.24. Usually we round it to just the 1 decimal, the tenth. So I may ask for the approximate. That's the decimal version, or the exact, something like that. So that is circumference. So circumference is the distance around it. The area is like the area of the shaded region. So this is actually measured in miles squared. This is just straight up yards, like I'm walking around it. So when I did that, some things came up. We started talking about sectors. Well, what is a sector? Well, I'm going to use the same one. If this is a radius 6, maybe I take it like a right angle here, and I want to say, what is just this area? So the whole area up here was 36 pi. What is just part of it? Well, let's pretend that was a right angle there. So what do you do for this one? Not going to give you this formula. It's the angle you're looking for, the central angle, 90 over 360, times it by pi r squared. Well, in this case, it was 6. So how do I find that area? Well, 90 out of 360 is really just 1/4. 1/4 of what? It's 1/4 of 36 pi. So what is that? That is just 9 pi. And again, this is miles squared. So, and I can still do this one, leave it in terms of pi. You're just finding what part of the circle is it. Then even from that, we could build farther off, and we could do segments. Let's say I still have that 90, but now I'm just looking at this chunk up here, so I just want this area. So it's getting even smaller. So what do? Well, first you find the sector. There it is, 9 pi. Then you find the area of this triangle, and it happens to be 6 by 6, which is great for me, because how do you find? That's the base and the height. So it's 1/2 base times height. And that's going to be what? That's going to be 18. So the area of the triangle is 18 miles squared. The area of the sector is 9 pi. So what is the area of this little chunk left over? What do? You subtract them. You take the sector minus the segment. So that looks like an anchor. That's kind of crazy. So we've got 9 pi minus 18. That's going to equal the area of your segment. You can leave it like that would be the exact answer. If they now want it approximate, you could just multiply that out. 9 pi minus 18. What is that little shaded region? It is 10.6. So 10 point, or was it 26? 10.26. I'll make that 10.3. And again, this is an area, so it's miles squared. That is the area of just this segment right here. Holy cow, that's intense. That's about the hardest problem on the whole thing. How does this relate to circumference? Well, circumference is walking around it. So if I gave you an arc length, maybe I did the same thing. Let's do the same numbers even. Let's just do a right angle. And now let's mix it up. Let's get a little crazy here. Let's do something more like, I don't know, 180 be straight across. Let's do 240. So I'm talking about this angle here. This is a 240 degree angle. So I want to find the arc length created. So the arc length would be the measure if I walked from here to here. So sector is you're actually finding the area. Like what is the area of this? This is the distance walked. So again, it's the same formula. You're walking 240 degrees of a 360 degree circle, times it by the arc length, or the circumference. It's what part of it. 2 pi r, in this case r was, let's use that 8 again. So I've got something like this. And again, reduce the fraction. What is 240 over 360? Or just type it all in. I'm cool with that. You can really just say 240 divided by 360 times it by 2 times it by 3.14 pi times it by 8. There it is. Boom. That is 33.49. So 33.5. And again, this is going to be in yards, let's say. So that's how far you walk, 33.5 yards from there to there. So the whole circle would have been 50. If I walked the whole circle, I walked 50.2 yards. I only walked 2/3 of it, so I walked 33.5 of it. Awesome. Other things with these arcs, you can measure arc lengths. So it kind of got covered up there. If I'm looking for, this is the notation, this DH here. Can I highlight that? So you're looking for the measure of DH. So you can find the length, arc length, like we just did. You can actually find it. If you're finding the measure, it's just how many degrees is the central angle that makes it. So if I have this, I know that's 52. Remember vertical angles, 52. That's 58 on the outside. So if the arc's 58, the central angle is also 58. Can I find more? Sure, this is a semicircle here, cuts it to 180. So 180 minus 52 is what? Boom. It's not 118. Why did I write 118? What is that? How about 128? So that's 128 degrees. So I'm looking for the measure of the arc length D to H. So I'm looking for this measure from here to here. Well, if that's 128, we call this 128. So if you're looking for the measure, you're looking for an actual degree. If it says find the arc length, you're looking for how far would you walk. That's the slight difference in those. That's the whole chapter. I hope you do well on this test. Good luck. Peace out.